Welcome to Eager Space. Every few months, I like to ask my subscribers, viewers, and supporters for questions that they would like me to discuss, and then I put my take on those topics in a video. This is the 6th edition of Spaceflight Topics. This time I took the top 10 questions that showed up in comments, added a few extra questions from channel members, and a couple that I just decided I wanted to answer. If we put Raptor 3 engines on a Falcon 9 class rocket, how capable would it be? I'll start with this video, though it's a bit out of date. The main issues are that the Raptors are just too powerful for a rocket that size. You want the engine sized appropriately for the rocket, and I don't think 9 Raptors would fit as the nozzles are too big. You could go with a smaller number, perhaps 3, but then you probably can't land the thing, because even at its lowest thrust, a single Raptor is just too powerful. And then you'd have to rework the design of the stage because Methalox rockets need different fuel tanks than Kerolox rockets. As for capability, it would be 15.957% better in terms of delta V, if you trust my numbers, and you probably shouldn't. What is, in your opinion, the best weight class for a reusable rocket? The usual question for designing a rocket is, what are you going to do with it? What market are you trying to serve? If you want to launch small satellites, Falcon 9 is a decent size, but if you want to launch big Starlink V3 satellites, it's too small. Each company has a different idea on how to make that trade-off. Starship has a giant payload, New Glenn is a bit smaller, Neutron is still smaller, and Stoke's Nova is the smallest of them all. There's no general answer. It's all about the market and the trade-offs. Is a private spaceport that is not owned by a rocket company a viable business? Where would you put a private spaceport? Here's a video that covers that topic in some detail. It all depends on where you want to launch from. SpaceX and Rocket Lab created their own launch sites at Boca Chica in Texas and New Zealand. It was relatively easy for Rocket Lab as they had a motivated government and their launch site is a remote peninsula on the North Island, with pretty much nothing closer than 8 miles to the launch pad. SpaceX's Boca Chica launch site is near a seashore and 5 miles from some very expensive seaside real estate on South Padre Island. They have a good relationship with the local and state government, but building a new launch site in the US is very difficult. Neither of those sites are open to other companies. I know of 2 examples of trying to do what you propose. In 2012, in Camden County, Georgia, the Joint Development Agency voted to explore developing an aerospaceport facility, using a site that had been considered as a NASA launch site in the 1960s. Like Cape Canaveral, the site is next to a national seashore, and the proposed flight path would overfly inhabited areas. In March 2022, the project was rejected by Camden County voters in a referendum, where 72% voted to halt the spaceport project. The second attempt was successful, creating Spaceport America in New Mexico. The state of New Mexico and local taxpayers spent $218 million to create a spaceport in the middle of the New Mexico desert. It is mostly a small hangar, sized for Virgin Galactic vehicles, with a small public viewing area on the right. Virgin Galactic has flown out of there and may fly again if they finish their Delta-class vehicle, with Blue Origin's step back on New Shepard for 2 years, and the likely result that it will actually be cancelled. Virgin Galactic would have the suborbital tourism market to themselves. Up Aerospace has a launch site located about a half-mile from the spaceport building that they use for suborbital launches. I'm assuming they use some of the office and hangar space in the main building. I would be interested in some more details on what you think about Stoke. In your Which Rocket Reigns Supreme video, you talk about how your opinion on them has improved, and that you thought they had bitten off an appropriate amount of technical challenge. Do you still think this, and do you still believe they have a chance to compete for launches? I don't really have much to add to what I've said in the past about Stoke. It's all going to depend on whether they can develop their second stage technology, and how much payload it will cost them. There's a lot to like in metallic heat shield systems over the tiles, because you don't have the issues of trying to keep the tiles attached, and they should be lower maintenance. But remember that atomic oxygen in the upper atmosphere eats everything, as we saw from the Starship metallic tile experiments. What I'm looking for is simple. I'm looking for hardware in flight test. Hoping to see that soon. How much do you think Jared Isaacman will be able to shift NASA's and Congress's ways when it comes to costly programs that benefit Congress? I wrote a big answer to this question a while back, but things have moved quickly since then, and I don't think that they've settled down yet. My current answer is way more than I expected, and the important part is that it appears that he has the backing of at least the authorization side of Congress, the one that tells NASA what to do. We won't know about the appropriation side until later, and Congress has told NASA to do something and then allocated little money to accomplish that multiple times in the past. So that is still an open question. Do you think Vulcan will ever achieve any reusability, or what is the future for ULA? Especially with Tory Bruno jumping ship for Blue Origin. I am utterly confused by ULA the past few years. In 2020, they won a bid to launch National Security Space Payloads, the biggest Department of Defense launch contract, on their upcoming Vulcan rocket. But since Vulcan wasn't flying yet, they included Atlas V as a backup option. Then, 1 year later, they sold all 9 remaining Atlas V launches to Amazon for their Kuiper, now Amazon Leo, constellation. The Department of Defense has not surprisingly been unhappy with this decision, as Vulcan slipped many years. They decided to annoy their bread and butter customer, the Department of Defense, when they sold every last Atlas V to Amazon rather than using them to launch NSSL payloads, as they had promised. They supposedly have plenty of Vulcan airframes and BE-4 engines available, but they just are not flying them. Like pretty much every company with a new rocket, they have been over-optimistic about their flight rate, but to go from 2 flights in 2024 to only 1 flight in 2025 is not a promising pattern. They do have issues with trying to fly both Atlas V and Vulcan from the same pad, and changes to allow them to do integration operations more quickly and in parallel are just coming online now. But Vulcan was scheduled to fly in 2021, and they knew they would want to fly both Vulcan and Atlas V. Construction always takes time, but this just seems slow. As for smart reuse, it was always a long shot because it's just not a very exciting architecture. You save the engines and that's useful, but the amount of work you need to do to get them flying again is considerably more than the architectures that reuse the whole booster. If they become the main launcher for Amazon Leo or some other constellation, that could give them enough business to make smart reuse worthwhile. Late in 2026, Tory Bruno and the rocket horse Indigo trotted over to a new home at Blue Origin, where he will be in charge of a newly formed national security group at Blue. Many of us know Bruno only through his work at ULA, but he had a significant career at Lockheed Martin, where he worked on missile programs and was the vice president of strategic and missile defense systems before he left. That experience, plus his experience working with NSSL on launch, will be very useful for Blue. Tory Bruno was the CEO of ULA, and therefore in charge of the company. But not really. ULA is co-owned by Boeing and Lockheed Martin, and that means Bruno didn't have a free hand to take ULA where he wanted to take it. He had to convince both Boeing and Lockheed Martin to buy into future plans, and both of them have broader concerns. My guess is that there was something weird going on at ULA related to the co-owners, and Bruno wanted to speed things up, and he finally decided it just wasn't worth the hassle. And on top of whatever else has been going on, ULA has had issues with the GEM 63XL solid rocket boosters they buy from Northrop Grumman and use on Vulcan. They had a booster nozzle problem on their second flight in October of 2024, and then another nozzle issue on the 4th flight in February of 2026. Vulcan is currently grounded until they can figure out what is causing these issues. For a conservatively designed rocket from a company with a long history of success, Vulcan has not been going well. Not well at all. Mr. Space, I have a question. What is your favorite fuel and oxidizer combination? You can call me eager. I love all of my fuel oxidizer combinations equally. I do recommend John D. Clark's excellent and highly entertaining book, Ignition, which you can find for free online. What are some practical uses for the Lunar Gateway space station? I did a video a few years ago, but I'll give you the quick answer. There aren't any. You can do science on it, but you would probably be happier with dedicated probes. You don't want your schedule to be tied to Artemis astronaut flights. Maybe you could do some experiments more cheaply. Flying on SLS is a lot easier than launching payloads yourself, but I don't think that's a significant benefit. If you want that benefit, build a small probe and either launch it directly as a co-payload with SLS, or send it on one of the landers and have them toss it out near the moon for you. Gateway can hold astronauts, but only for short periods, and it's really cramped. And right now, the only way to get there is on Orion using SLS. It looks comically small when you think of a Starship connected to it, and even Blue Moon is pretty big compared to Gateway. It exists for purely political reasons. It keeps Johnson Spaceflight in the space station business, and gives a reason for SLS Block 1B to exist. Those seem likely to be going away. What does Relativity Space have to do to compete with Rocket Lab? Here's a video for you to watch. Unless you are trying to do something unique and innovative, like Stoke with their plan for second stage reuse, you're mostly just wasting your money. The existing companies have all the advantages. They have their factories and launch sites built, they have contracts that are bringing in revenue, and they have economies of scale. And launch isn't a great business to be in because it's hard to differentiate. Pretty much everybody can launch into LEO, so you're fighting based on schedule and price, and that ends up as a race to the bottom. SpaceX built a groundbreaking commercial launcher and then pivoted towards Starlink, and they are now a communications company that happens to launch rockets. Rocket Lab was a small company working on the small electron rocket, but they bought into Space Systems, and that part of their business generates more money than their launch services. Together, those two parts makes them a one-stop shop for companies who want to be in space. ABL abandoned their RS-1 launch vehicle, rebranded their company to Long Wall, which I unfortunately think sounds like a Chinese company, and are now focusing on missile defense and hypersonics. Firefly is working on their new medium launch vehicle, but they have landed their Blue Ghost vehicle on the moon and are working on the Elytra orbital transfer vehicle. ULA is one of the few pure launch companies left, and we can see how well that's working for them. I don't see much chance of Relativity being successful. They're competing against Falcon 9 and Neutron. Why would customers want to choose them over the alternatives? Where will the demand for 1,000 Starship launches per year come from? And how long will it take the market to respond to the decrease in launch costs? There's clearly not an existing market. Moon and Mars settlement is one possibility. Mega data center constellations are another one. Neither of these is near term, so 1,000 launches per year is purely speculative to me. What could be the next big tech innovation that will cause significant price reduction after Starship? What's holding us back? I've been waiting for one of my supporters to buy me a real crystal ball from Tibet, but there haven't been any takers. Lacking that, I don't have any real insight. I assume you're talking mostly about launch. I don't see any big tech innovations on the horizon. Stoke's model might end up being better than Starship's, but it probably won't be a huge difference. The launch market will be driven by people willing to spend money to put stuff into space, and that mostly depends on there being useful reasons to do that. What will happen to SpaceX when Elon dies or retires? Will the company continue with their ambitions for Mars or refocus towards Starlink, low Earth orbit, and the moon? This is a significant question, especially with the recent mergers and the upcoming IPO. I made this chart for my What Would Falcon 9 Do video. It shows that the time where Elon was off doing other stuff, Twix and political stuff, is just before the issues with Block 2. I therefore theorize that, at least for Starship, Elon is a required component of the development process that SpaceX uses. If that's right, then we should rightly be concerned with not only Elon getting older, but with him getting distracted with AI, orbital data centers, and anything else that might pop up. What is your opinion on the currently known specs of Rocket Lab's new Archimedes engine, and what specs will it need to be a competitive engine for Neutron? I'm not sure the currently known specs are the actual specs. I do know that one of Rocket Lab's goals is to build a lightly stressed engine, and with their lighter airframe that makes sense. They can always uprate later. Rocket Lab attracts some extra attention because they are one of the few publicly traded new space companies, and they therefore have investors who are less space savvy and those who want to, or have, shorted the stock and want to see the value go down. It is true that Archimedes development is taking longer than Rocket Lab hoped it would take. That's rare. Most engines stay on schedule. Just look at the RS-25, the BE-4, and the Raptor. All were done right on time. What do you think was learned from the short ownership of Phobos and Deimos offshore platforms? Offshore platforms put you back in the marine assets business. You need a way to get propellants out there even if you only launch tanker flights, plus a way to get payloads out there if you want to launch them. Ships are expensive and you can get delayed all the time. Maybe when Starship is flying all the time they might revisit them, but currently they make little sense. That's why they're building 2 launch pads in Florida and 1 in California. I would say that their ideas there were very premature, but they didn't spend a lot of money on the platforms. In the past, you've made some very compelling arguments against asteroid mining and other endeavors in general. Do the same obstacles make space manufacturing an absolute necessity for building large things in orbit, or is that problem not as clear-cut? Our big experience with space manufacturing was assembling ISS, and that took a long time and was finicky work. Doing manufacturing on Earth requires a very sophisticated supply chain that is spread across the world. Building real things in orbit requires duplicating enough of that from space materials, either from the moon or asteroids, to make it cheaper than just launching things from Earth. Let's take an example. If you're building solar panels, we need to go through all of these stages. The first step is the production of highly purified silicon, known as polysilicon. You obviously need a silicon-rich material supply before you get to this point. On Earth, that's fairly easy. It might be tougher in space. The equipment to produce polysilicon is big industrial equipment and takes lots of power. Some of the approaches require gravity to work. Then you need equipment to create silicon ingots. That equipment is also big and takes a lot of power. Microgravity will likely impact how this is done, though experiments have been done on ISS. You'll need to do this for each of the other steps as well. Everything you want to do is going to require research and development to figure out how to do it, investment to design and build the machinery, launch costs to fly it, and then some way to keep it running. Note that if you're depending on microgravity for what you're doing, humans make lousy roommates, because we are messy and need to exercise daily in orbit. That makes keeping things running much more complicated. Do you think any large space infrastructure projects, in orbit, on the moon, etc., are or will be feasible anytime soon? It's that word feasible that I'm having an issue with. Many are feasible in the sense that there are no laws of physics that prohibit them. Things like oxygen production and volatiles refining might be relatively easy. But the real question is whether somebody will do them, and that depends on whether there is a market to buy the finished product. Can a company build a case to invest the money in developing a specific capability based on the forecast market for their product? That is a really, really hard nut to crack. If you want to produce liquid oxygen on the moon, you can only vaguely figure out how much it will cost you, and you know that the cost from the Earth might go down, or somebody might manage to harvest volatiles from asteroids and compete with you. The real question is there a market? Would the Constellation program have worked better than Artemis? Would it have been cheaper, faster, or safer? I talk about the differences between the Apollo, Constellation, and Artemis architectures in this video. Constellation has the advantage of being an actual lunar architecture, rather than an architecture without a mission that was adapted to maybe work as a lunar architecture. Constellation was a 2-vehicle architecture. Ares 5 launched a big Earth departure stage with the Altair lander on it. Orion, with a much bigger service module, was launched on the Ares 1, and then they met up in orbit. From that point, it's pretty much like Apollo. It's a better architecture than Artemis, that's for sure. The problem is that NASA spent 5 years on Constellation and didn't really build anything useful. And with my usual standard being actual hardware in flight, I'm not super excited about the prospects. I think we likely would have ended up in a similar situation to SLS, but just a few years earlier. Can you discuss the return contingencies for the Artemis program? I know it's more complicated due to the near rectilinear halo orbit and limited delta V in Orion, but how will that translate to operations and contingencies? We don't have an Artemis 3 press kit, so I need to base things on the NASA diagrams, which means some of this is a little speculative. The answer is that the nature of the Artemis architecture means that abort and return contingencies are limited. When Orion and SLS reach the Moon, they will insert into a very elliptical near rectilinear halo orbit. This orbit takes about 6.5 days. During descent and landing, I expect that there may be some early options to abort and rendezvous back with the Orion. Later in the descent, Orion is probably too far away, and the only option would be to abort to low lunar orbit and wait there until Orion comes back around, in about 6 days or so. Once you're on the lunar surface, you're going to stay there for the whole 6.5-day mission, because that's how long Orion isn't reachable. If you have an issue on the surface, the longest wait before you can get back to Orion would be right after landing, and that would be 6 days. Once you get back on Orion, my reading of the diagram says that you have a half orbit before you can do your return to Earth burn, and then you have to get back near the Moon, and then you have 3 days back to Earth. Worst case, I'm thinking it's maybe 14 days from when you want to come back and when you get back. Best case, probably about a week from lunar surface to splashdown. Orion limitations mean that NASA was stuck using near rectilinear halo orbit. It bothers me that they pretend there are significant advantages of near rectilinear halo orbit. It's better for a space station, but Gateway is already a bad idea. For sake of comparison, a return from the ISS is between 6 and 30 hours. Apollo went from the lunar surface to splashdown in 3 days. That's a lot shorter than what we would see with Artemis 3. That's assuming Artemis 3 stays with this architecture. Now that it looks like the first landing is Artemis 4, and that will probably use the Centaur 5 upper stage, it's possible that they may switch to low lunar orbit, the same orbit that Apollo used. That would be a lot simpler and better from this perspective. Are you currently involved in any rocket stuff besides videos, either work or hobby related? I dug out my rocket box for you. That has most of my model rockets. I ran a 2-week rocket design, build, fly class at a school my wife used to teach at, and then I ran a similar class for my team at work and for a bunch of C# influencers during C# summer camp. That was probably in 2003. The simple rockets at the top of the box were extras that people didn't want after one of those events. I have a toolbox with all my range equipment and a bunch of extra motors, and I should find a good time to go and use them up. I did make a brief foray into high power. This is my daughter with my level 1 certification rocket, Spot. It's a heavily overbuilt Loke 4 that was built assuming I would use it as a level 2 rocket, which is a much more serious undertaking. At the point I built it, I could fly on a 5,000-foot waiver from a site 20 miles from my house, and that was very nice and very convenient. Then we lost that site, and the closest site is now 210 miles from my house. I like big rockets, but that's more time investment than I'm willing to make. So Spot has been resting in a closet for a couple of decades. Maybe I'll get back to it now that I've retired, but that hasn't seemed to be at the top of the priority list. What about rotating space stations? I have that on my list of topics, and I hope to get around to it at some point. Yes, I chose to answer this question just to make that joke. I have a 2-part answer. The first is that if you're going to do manufacturing in space, you don't want humans around as we are messy and move around too much. The reason to do something in space would be true microgravity, and that probably means you want a free flyer rather than a space station. If you want to build one for humans, it needs to be big enough so the rotation doesn't mess up people's equilibrium, and that means it's pretty big. I have 70 meters stuck in my head, but it's been years since I last read the papers on this. You could do it as a space hotel, but I think many people have overestimated how much fun it would be to spend a week in orbit even with artificial gravity. There is, of course, a video on that. And that's all for this series of topics. Today's song is Crystal Ball by Styx, from their 1976 album of the same name. I believe this is my all-time favorite Styx song.
Eager